Hello, my name is Jose Mesa, and this is a presentation on Storm and a Twitter feed for the Harvard Extension School, Big Data Analytics. So what is Storm? Storm is a real-time uh, distributed data processing computation engine. It was first developed by BlackType, which was later bought out by Twitter. Shortly after coming onto Twitter, it became a free and open source project, which can now be found on stormproject.net. So, how is Storm similar to other big data systems? Well, the most popular one is Hadoop. In Hadoop, you have MapReduce jobs. In Storm, you have what are known as topologies. A MapReduce job eventually ends. With a topology, it can run forever, since real-time data can be coming in continuously through a queue. In Hadoop, you have a job tracker. In Storm, it's analogous to the Nimbus. Obviously, Storm is real-time. Hadoop is batch-oriented. Both were created to handle big data, and both are distributed, which can run on large clusters. What does Storm have to offer? Storm has to offer easy integration. By that, it means that the source of the data, the streaming data, all you need is a data source, whether it could be a queue, a constant feed from Twitter tweets, or a existing database. The API is very simple to work with, very simple to deploy. As you'll see in the next slide, I'll go into the different components of the API. Storm is very scalable. It's been tested and it works. It's fault tolerant. If a node fails, it'll come back up. Another one will come back up if that one will come back. We'll restart. And you can build the different components with almost any language, and it's very easy to deploy. So this what we see here is a topology. A topology is made out of spouts and bolts. The spout being the source of the streaming data. Like I said in the previous slide, it can be a database or a tweet or any other source that you can think of. A bolt, what the bolt does, it processes the streaming data, and the bolt can be fed into, or it can emit data to a different bolt to do additional processing. And this is very easy to set up in your code. There are two run modes for Storm. One is the local cluster, which is used for developing and testing, and all you need is just your local machine. The second form is cluster. With the cluster, you can run it on multiple machines, whether it be a custom homemade cluster or on Amazon Web Services or AWS. To run Storm, it's a very simple command line. You just name your jar file and the class where your main method exists. In my in the demo that I'm going to show you, what I try to show is what DJs are being mentioned in tweets. So I took the DJ Magazine's top 100 DJs for 2012, and I searched for them in the Twitter feeds. I used an API, a Java API known as Twitter4j, to connect to the Twitter's APIs, or to the Twitter's streams. In the Twitter dev site, before you begin, you need to create an application. They'll give you a token and access codes. Here you see the topology for you see the code for the topology. First, what I do, I set the spout to the class that's going to be running the spout. In this case, it would be the Twitter stream spout, which requires the Twitter account and password. Here I've blocked it off. And then you set the bolt to read the emitting messages from the Twitter stream, and then which is called find DJ. And then count DJ reads the DJ names that it finds in the Twitter streams in the find DJ bolt, and keeps track and counts them. Here you see the code for the spout. Here I create using the Twitter4j API, I create a stream connection to Twitter. One of the problems that I was facing initially, I was using the sample method to read all the tweets from Twitter. But the problem that I was facing was that not enough DJ names were coming up. So it was taking a very long time for one DJ to be counted. So what I did is this is because not every single public tweet is made available to a stream. I read that it's less than 1% that are made available. So what I did to solve this is I created a filter so that it would only grab tweets that contained those top 100 DJs. Here you see the code for the different bolts. The first one looks for one of the for one of the top 100 DJs in the tweet, and it emits this. It emits the DJ name. Then the DJ count bolt receives this tuple, and it keeps track and it counts every single DJ that has appeared in the tweets. So here are the results, but instead of this, let me go over the code that I have and run the example live. So here what I did is I hard-coded all the top 100 DJs into a string array. And here you can see the okay. So this is the spout, and here's where we're making the connection to the to the stream, and here it gets emitted out to the receiving bolt, or whoever wants to receive this, the emitted message. Here again, I hardcoded the list of DJs into a string array, and in this bolt it finds the particular DJ that people are tweeting about in the received tweet, and then it emits that particular DJ right here. The DJ count bolt receives the messages from the find DJ bolt, and it keeps track and it counts how many DJs have been mentioned in the different tweets that I'm receiving. So let's go ahead and let's run the code. Here you go, it's initializing, connecting, making the connection to Twitter. And here already it's starting to count the different DJs that are coming up in tweets in real time. So I set it up so that it runs for 2 minutes, and you can change this time, or you can just let it run forever. And or another option, you can just stop it from here. So let's let it run for another 10 seconds. Okay, there, I stopped it. Here you see the different DJs that are coming up and how many times they're being mentioned. For example, here's Skrillex, which is being mentioned 14 times since I started the process. And I run this several times, and it seems to be that Skrillex, Tiesto, and David Guetta usually are the ones that are most talked about on Twitter tweets. And that's about it. This concludes my presentation. Hope you enjoyed. Okay, bye.